37 says, economic forces beyond anyone's control have changed the cost function for portaboys. And it says C of x equals 105x plus 175. Okay? They give me a cost function. And I've been wanting to talk about a problem like this for a while anyways. You guys have had a couple throughout the course on the homework. Rework example 2.1.5 with this new cost function. So we're actually going to turn back a couple pages, I guess to like 160, and we're going to look at the example. And then I want to talk about average rate of change and instantaneous rate of change based on this. I think this will kind of summarize what we want to learn about this. Okay? So let me write down the cost function. So they give me this function, C of x equals, this is section 2.1, number 37. And they say C of x equals 105x plus 175. Now, the claim is that this is a linear function. How do you know? It's degree 1, right? The variables, the only exponent you have, I guess, is a 1 that we don't even write down. Okay? Also, there's another way you might recognize that this is linear, and that is because it's in a very familiar form to us, right? And what's that form? Y, right? Where it says f of x, or c of x in this case, we can write y equals mx plus b, right? And this b is the what? The y-intercept. So graphically, this cost function looks like this. This is x over here. And along the y-axis, instead of writing y, what am I going to write? Well, c of x. Because that's our actual function, right? And so what it tells me is that we have a point somewhere on the y-axis. I'll put it about right here. And what would be the coordinates of that point? Okay, so if you're using x and y coordinates, you would write 0, 175. There's another way to write that using this cost language. We could say that c of 0 is 175. All right? Now, I want to turn to the example. They say 2.1.5 is what this is based on. And I want to read that again. Because it says this is the cost in dollars to produce X Portaboy game systems. All right? So that's what we're saying this is a cost function about. Somehow this represents the cost of producing Portaboy game systems. All right? And so just as another example, well, here I have a point, right? I want to graph another point. I'd like to compute C of 10. What would C of 10 be? Well, that's easy, right? 105 times 10 plus 175. So that's 1050 plus 175. Are you guys getting 1225? Right? So somewhere up here, well, now I have to scale things differently, right? So, I don't know, somewhere up here, if I have 10, I have a cost of, well, 1225. C of 10 is 1225. So if I'm going to draw a sketch of the graph, I guess that's about what it looks like, right? It's a line. I don't have any graph paper here. All I know is it's a line and it's increasing. Okay? So the next question says, how many Portaboys can be produced for $15,000? Well, I guess in order to understand that, we should be careful about what x and c of x represent. What does x represent? That's the number of Portaboys that you're producing. C of x represents what? The cost. So I like keeping track of what the variables represent. Hey, so this first problem I did when I did C of 10, I think this is important. How do we interpret that? What's the interpretation? What would that be? So cost of producing what? Yeah, how many porta boys? What's it say? If you want to produce 10 porta boys, right, it would cost how much? Sure, $1,225. And if you're going to do that, how much should you sell them for? Yeah, I mean, you figure 10 of them. Actually, I think a lot more than 12, right? The cost per item is how much? Well, 10 of them for $12.25, so I'm going to pay $122 to make each one, right? So what do you want to sell them for? $150? Now $149.99, right? You'll sell more that way, okay? But we want to make a profit. You guys with me? Okay. So now it says, well, we have more money than just this. We have $15,000, okay? So what do we want to do? So, question 2 in the example says, how many porta boys can we produce for $15,000? All right, I'm going to pause and let you guys talk about how you would solve that with the person next to you. It's a good thing to do. So I heard a bunch of people talking about using this function, and when they gave me $15,000, what did they give me? They gave me the cost, right? And so where do I put that $15,000? I put that in as the output of the function, the C of x. And now if I solve for x, x, remember, represents how many porta boys? So you guys were doing that, and you got, what was it? 14,875 equals, no, 825 equals 105x. Did that work out exactly? No? What'd you get? You can make, how much? 141.2. So how many can you make? Yeah, you can't make 0.2 porta boy, or if you do, it's not going to sell, right? So I guess I would answer this question. We can produce 141 of these porta boys. Okay. Moving on. As we go through the example, the rest of this doesn't change too much. Explain the significance of the restriction on the domain, x bigger than or equal to 0. Why do we have that? Yeah, it's because you can't have a negative number of porta boys. You can't do that. Now, I want you to understand this is different than other domain problems we've had, right? Sometimes you get x is greater than or equal to 0 just because of the model you're using, like a square root function. We said we can't take the square root of a negative. Here, the reason x is greater than or equal to 0 is because we're interpreting this as a particular idea. It's a number of game systems. All right, number 4. Find and interpret C of 0. We already found it, but let's interpret it. How do you interpret that? I interpreted C of 10 okay, but how am I going to interpret this C of 0 equals 175? Could you talk to someone next to you about that for a minute? What do you mean by that? What is startup money? Jack says this is startup money. What is that? Yeah, I mean, you know what I would call this? There's a business term, and when I teach the finite math class, which actually some of you could take next semester if you're interested, I know Connie Shikani will be teaching it next semester, but we talk about interpreting the mathematics in a business situation. These are what you might call your fixed costs. Okay? Now, what are fixed costs in the business situation? I mean, is it really going to cost me $175 to produce nothing? Well, yeah. If you own a factory, I'm sorry. Even if even if you're closed for today, you got to pay those workers. You got to pay the lights. You got to, right? There are fixed costs you have to pay. And then, maybe the next thing to interpret is the number 105. And this is along the lines of what Barb asked me at the beginning of class. We say here that the slope is 105. Okay. But usually when we say slope, what's your definition of slope? Everyone knows rise over run from their algebra class, okay? And that's not bad until you get to this situation, like what do we mean rise over run? Well, if you say in terms of variables, usually that's like change in y over what? Are you guys familiar with that delta symbol for change? Is that okay? Okay. So change in y over change in x. But here, x actually means something. X stands for what? Number of Portaboys. So how many of these game systems you have. And what about y? What does y stand for in this problem? Or C of x? Cost, and what are the units? Dollars. Okay, so somehow, when I understand that 105 is rise over run, I should think of this as $105 per Portaboy. It's a rate. Now, usually the only rate I ever think about is me trying to get here on time at 8 in the morning, and I'm driving what? 70 miles per hour, right? That's the per. Is it really divided by? Well, sure. Because if I'm driving 70 miles per hour and I go 140 miles, how long does it take? 2 hours. Now, am I really going to be going 70 the whole way? No way. Through Kirtland, you better not be driving 70, right? I mean, there comes a point where you got to slow down, and then maybe somewhere else you speed up. But what we talk about is my average rate. And all of a sudden, we're getting at the idea of slope. Slope being an average rate of change. When we say slope, we're talking about, and this is a special idea, the slope of a secant line. Now, I have to say what I mean by a secant. A secant touches 2 points. And so I just want to touch upon what Barbara was looking at in the book. Okay. It's 1 page later, right? Mm-hmm. Example 2.1.7. Recall that the revenue from selling X units at a price P per unit is given by this formula. Suppose we're in this scenario where we're making these Portaboys. Find and simplify an expression for the weekly revenue as a function of the weekly sales. Okay? Now, do I have a formula for R of X? Well, I guess it's X times the price, all right? So they said we had a price function, which was linear. Okay? See that? How do I know that's linear? Well, it's mx plus b. You guys with me? By the way, as you increase x, what happens to the price function? Does it go up or down? As I increase x, if I put in a larger value of x, what happens to the price? That makes sense, right? If I make more of these portaboys, I can start to automate things. And actually, that's why the rate of change is negative here. Do you guys see that? It says, since we determine the price-demand function here, R of x is restricted to these values. All right. And then they're going to go ahead and do a slope. I think it might be nice for me to do another example to show you how this works. I mean, we can read, but for me to read to you gets kind of boring. Okay, let's do that one. Page 166. This is section 2.1. Page 166, number 55. This problem keeps coming at us. So we just talked about it a lot because it's a parabola, right? So we have this model. Again, f of t is negative 0.0076 t squared. And then it says plus 0.45 t. And it says plus 16. It's the same function. Yeah, that's why I want to do it. It's one that people asked about, too. It said, find and interpret the average rate of change over the interval 0, 28. Okay, let's see if I can do that. Find and interpret the average rate of change. That was a concept I went over with you guys 2 days ago. And I want to come back to it now. Find and interpret the average rate of change over, and then the domain is 0, 28. Okay? So we learned that the vertex is past the domain, right? Oh, by the way, something on the homework last night. They asked if a function was increasing or decreasing. I want to talk about that. Here, let's look at the graph of this function. And by the way, that vertex is where? That's at 29.6, right? So I would say that this function is increasing from 0 up to where? 29.6. And after that, the function is decreasing. I think of it as driving a car. You always drive a car across the page from left to right. Is the car going uphill? That's increasing. Is the car going downhill? That's decreasing. And so now if you think about your absolute value homework, you're going to have parts where you're increasing and parts where you're decreasing. And then some of those you even had, remember the example yesterday? It was flat for a while? Okay, that could be, constant, not increasing or decreasing. Well, anyways, for this function, for this problem, we're only looking at the domain 0, 28. Are we increasing or decreasing? We're increasing the whole time. Does that make sense? Because as we go from left to right, here, let me show you how to do this. This is kind of cool. Well, okay. You'll see. Here is the input 0, right? As I drive from left to right, I'm going up, 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 up until I get to 28. I've been going up the whole time. That's an increasing function. That's what I mean by increasing. Now, when they say the average rate of change, that means the slope of, and then there was a vocab word I gave you last time. Do you remember what kind of line it was called? It's called the secant line. And the secant line is a line that intersects, it's intersecting 2 points on the curve. And this is a really nice example, so I'm glad we're doing it. I need to draw a picture and show you what exactly we're doing. The function, well, is a parabola, right? Remember, the vertex was at like 29.66. But what we're doing is we're only going on the domain here from 0 to 28. Right? We're really only looking at this piece of it. Are you guys with me? Okay. Now, when I say I want to draw the secant line, that's why Lakeland gave me an ID. I told you guys that, right? Not to get into the AOC. It's for your math class. You always wondered. So, the secant line, let me draw that in purple, goes from this point at 0 up to this point at 28. And so, what I'm saying we're trying to find is the slope of that line. That's called the average rate of change. So let's do it. Well, how do I find that slope? Well, yeah, we need the points, right? Because we know that m equals, well, y2 minus y1 over x2 minus x1, right? You guys know this formula? Let me write it differently. Let me write it as, how about this? F of 28 minus f of 0 over 28 minus 0. How's that look? Does it make sense? Because that's what the y-coordinates are I'm going to get by figuring out what the function. And the x-coordinates are here. So this is going to be easy because the denominator is just going to be 28. What is f of 0? That's easy also. That's 16. Now what about f of 28? Well, not as easy. But luckily I have this calculator to help. And I want to show you a little trick you can use. I'm trying to find f of 28. So I'm going to do this. I'm going to hit the second key, and I'm going to press where it says trace. This calculate menu is really nice. Now, before I showed you how to do minimum and maximum. Right now I'm going to show you how to do a value. I'll press enter. And you type in an x, and it'll type out what f of x is. So I'm going to type in 28, and it finds it for me. It tells me the output is, well, 22.64. Actually, it's pretty close to the vertex, right? Because that output was 22.66, I think, or something like that. Anyways, what is 16? That's f of 0. Let me show that. If I hit second calculate and put in a value of 0, it spits out 16. Yeah, you can't see that with the light. But actually, I knew that would happen without the calculator because I just looked at it and I said, oh, those are all going to zero out, and that'll 16. Okay? So f of 0 is easy to find. All right. So this tells me the slope is, I guess that's 6.64 divided by 28. Let me work out what that is. I got 0.237. Okay, cool. 0.237 what? What are the units on this? Well, the numerator, those are in miles per gallon. What's the denominator? What are the units in the denominator? You're almost out of gas, guys, but I only got 1 minute. Stay with me. No pun intended. Year. All right, so we have to interpret it now. How's this a rate of changing? Well, here's the game. Over the 28-year period, the MPG increased an average of what? 0.237, yeah, miles per gallon per year. So about every 4 years it went up 1 mile per gallon. Notice that's an average. It really increased at the beginning. At the end, not so much. So maybe that'll help your understanding a little bit. I hope so.